Hi, and welcome to Talk Digital to Me, where I explore the latest trends and topics in digital, tech, AI, and online media, and hear from the people working in the industry. In today's episode, we're going to be diving into the world of healthcare innovation and how AI can save your life. I'm your host, Nicole Martin, and this is episode 2, a check engine light for your body. This episode is exciting for me because it has to deal with an industry that I currently work in, healthcare. I work as a digital personalization manager for a major healthcare conglomerate on the digital marketing team. What that means is I do personalization strategy and implementation on the website and write rules to make the site change based on visitor behavior and personalizes their experience. While this is far from saving lives, curing diseases, or even helping to build some of the amazing technology in healthcare, I do get to play a small part in helping people find what they need faster on the site, which is pretty cool. So of course in healthcare, there is no lack of new innovation and discovery every single day. And each time it gets more advanced and unbelievable. And we could go on all day about the scientific discoveries, but my expertise is in tech. And one of the craziest things about tech innovation in healthcare is the fact that some of that is coming into our everyday lives, like fitness trackers. And yes, fitness trackers aren't serious medical devices. Please don't use it as one. Maybe you have a Fitbit or an Apple Watch that tracks your workout, or like mine, tells you you're sitting too long and you need to get up and move. But imagine if that tracker could read your heart rate as accurately as an electrocardiogram, the kind that doctors use to diagnose abnormalities before they cause a stroke or heart attack. And that saved your life. Well, that may not be as far off as you think. ECG-enabled smartwatches, made possible by new regulations and innovations in hardware and software, offer the convenience of a wearable device with something closer to the precision of a medical one. And I happen to be talking to someone today who knows all about that. Stay tuned. He is heading the data science team, and he is the co-director of artificial intelligence at Mayo's Clinic, cardiovascular medicine department. 4 years ago, he joined the Mayo Clinic to use his passion for algorithm development and coding to advance medicine and improve patient care. Some of the innovative products that he and his colleagues started were licensed to Silicon Valley-based companies, and 3 of them are currently in FDA approval process. So, hi, Zachi. Welcome to Talk Digital to Me. How are you today?
Great. Thank you, Nicole, for having me.
Absolutely. Thanks for being on the show. So I wanted to talk to you a little bit about your background and education, a little bit more about your role at Mayo Clinic. So if you want to talk a little bit about that.
Sure. So I always loved computers. I was programming and writing code since I was a kid. But it really started after the Army service. I joined a startup company that we built software to try to predict disease outbreak in chicken coops. And that was the first time I actually wrote software that talked to physical sensors and used machine learning to predict diseases. I really liked it, and I decided I really want to dive deeper into the math and theory behind it. So I started my electrical engineering school and in Ben Gurion University in Israel, and most of the time I spent most of the time studying signal processing and machine learning. I really liked it, so I continued to a master degree in machine learning, and then I discovered about an option to do a joint research with Mayo Clinic. The focus of the research was trying to estimate potassium level using ECG alone. Sounds very exciting to me. I didn't really know what potassium, I didn't really know how it affects people. I just knew it's going to combine coding and machine learning with helping patients. When I first got here, I understood that potassium is actually a very important electrolyte, and people with kidney failure or heart failure have a hard time keeping equilibrium, and it actually causes sudden death. So
Oh,
a
wow.
person can have hyperkalemia or higher levels of potassium in his blood, thinks everything is okay, and start a fatal arrhythmia and just die.
Oh,
The
my
only
gosh.
way to monitor today is using blood. And most of the patients that are monitored for potassium are monitored once a month or once a year. And that's something that can really change a lot even during a single day.
Yeah. So tell me a little bit more about these ECG readings and how that's helping to, drive healthcare innovation. You learned about these sudden death stuff. So what are you working on that's, helping maybe prevent those things?
Yeah. So an ECG it's a recording of the electrical activity of the heart. Every beat, the muscles of the heart are getting synchronized by electrical signal. And by recording that signal, we can see if the heart is working properly. In our last work, we actually said, well, we know arrhythmias or problem with the heart conduction system is easy to detect using ECG. Maybe we can do more with that. So a group of colleagues, mostly physicians in Mayo Clinic, and I met and looked at all the biggest diseases that we have. You probably know, but the biggest cause of death in men and women together is cardiovascular disease.
Mm-hmm.
We hear a lot about cancer, but cardiac diseases are the number one killer. And when you look at a specific disease called heart failure or left ventricular dysfunction, it's 2 to 9% of the population in US have that disease.
Yeah. Why do you think that we don't hear a lot more about cardiovascular and we hear more about the cancer stuff if cardiovascular is still the top leading death? Like, I'm actually surprised to hear that. I knew it used to be, but I didn't know it still was because I hear so much about cancer and everything.
Yeah, so probably because of our diet and our more modernized life, we sit a lot, we exercise less. Mm-hmm. Cardiac diseases are a big problem. We also live more. And this is one of the things, just by monitoring, we can actually treat. So heart failure, the disease we focused on our last paper, is something that has the 5-year mortality rate of about 50%, and it's worse than some of the more known cancers. When you think about it, the main reason is that for a lot of these patients, the symptoms starts later in the disease. So a patient can have a disease without him knowing about it. He will go to the provider one day, and then he'll discover he has severe heart failure.
So how does it work exactly? How are these procedures and testing? How are you making them more efficient, and how does it work?
So we want to be at the point that you don't have to have symptoms to know you're sick. So you can think of someone going to his annual physical testing and getting a regular ECG. It's a 10-second test, non-invasive, has no radiation or anything like that. It's a pretty cheap test as well. And in the background, we're running these AI models. These AI models were trained on hundreds of thousands of patients here at Mayo, and we correlated the ECG with multiple outcomes, heart failure, potassium, and so on. In the background, we will see if that patient have a higher risk or even has already heart failure as a disease. We will then send them to an echo. An echo is an ultrasound of the heart. Mm-hmm. This is a more expensive, more precise exam, takes about an hour to do, and it's great for diagnosis, but it's not something we can apply for screening. And using the ECG for screening with AI will allow us to send only the people that actually need an echo to do an echo and get an early diagnosis. Treating that disease early would really help them and improve their chances to recover and extend their life and improve their life quality.
Yeah, so how accurate are these procedures and testing at the moment with this AI and machine learning?
So we were surprised actually because looking at an ECG and saying what's the ejection fraction, it's basically a number that tells you how well your heart pump is working. It's not something that a human can look at and say, well, you have a low ejection fraction or the beginning of a heart failure. Maybe there are some physicians with tens of years of experience, very unique ones, but it's not something that's scalable. If you go to your physician, he wouldn't know how to do it. So we weren't sure what we should expect there. And we measured the results using the area under the curve. It's a number that says how well your test differentiate between the two groups of patients, in our case, patients with low ventricular dysfunction and patients with normal ventricular dysfunction. The number goes between 0.5 to 1, and most tests used today have between 0.7 to 0.9. So 0.8 accounts for a very good test. The AUC for the low ejection fraction detection was 0.93. It's higher than most of the tests we're using in clinical practice today.
Wow. So with the accuracy and, predictive nature of machine learning, do you ever get doctors concerned that AI will take over their jobs? What do you say to those who are worried about AI taking over medical jobs?
Yeah, I think that's a great question. When we started, I got an email from someone saying, is it a Skynet scenario? Are we going to be, are we going to see AI instead of a physician, and no one will care about me anymore? And I think it's just the opposite. There's a new book coming by Dr. Eric Topol. I just saw on Twitter the first page of it, the cover. It says making healthcare human again when talking about deep learning. And I think that's exactly it. I think using AI will help physicians focus on the patient and less on the technical side, less on looking at the test and going over the more technical things. And it will augment them. It will help them do their job better by looking at things that physicians don't know how to do. When you think about 20 or 30 years ago, when Microsoft started selling Office and Excel, I'm sure accountants were worried that they won't have their jobs anymore. But it didn't replace accountants. It just helped them do their job better. And instead of focusing on summing all the numbers and not doing mathematical errors, they were now focused on the actual problems and helping their clients.
Yeah, I think that makes perfect sense. I just had something come out with they're doing journalism where it's AI predictive, and it actually talked about that too, where journalists can now concentrate on the content behind what they're writing about instead of doing that. So, it's funny how no matter what field you're in, AI is having kind of an impact on these fields, and people get a little weary, but, overall the message is that these AI and predictive machine learning programs are going to help people do their job rather than replace them.
Exactly. And I think working here in a hospital, so our team is actually embedded in the cardiology department. Our lab is inside the fellow's office, and we sit shoulder to shoulder with physicians. And I think it gives us the balance of working, understanding the actual disease, working with domain experts, because you hear about the move fast, break things that I think started at Facebook. It's not something that can work in healthcare, right? There's literally lives on the line here. And I think working with physicians and engineers together allows us to move fast but not break things. Understand that our models have actual meaning, and we answer relevant questions, and we find things that we can help patients with. We'll focus on the stuff that can actually benefit them.
And I think with that benefit, comes teaching people how to do things. Like, I think AI is a great tool for med school and learning. Can you speak to that a little bit?
Sure. I really think that using AI to try to uncover some of the mechanism of diseases that we don't know about yet can really help improve healthcare and healthcare research. Think about models that can do stuff that humans cannot do. Maybe they can show us what did they find, and, for example, what in the ECG specifically predicts a low ejection fraction. Because, for example, in our work, we noticed that even when the system was wrong and the AI thought the patient is sick, and the echo and the physician say he was healthy, he had 5 times higher chance of developing the disease in the future. So it's almost like the AI predicted the disease. If we can go back and see what in the ECG made the AI model to understand the patient is going to have the disease, maybe we can teach it to physicians. Maybe we can help them find signs of disease much earlier.
Wow, that's excellent. That's just crazy to me. That's almost like magic. That's where that, line between science and, crazy is just, there. I can't believe that, a machine would know, okay, well, they're not sick right now, but, 5 times more likely to get sick in the future. That's just complete innovation.
Yeah. We actually think that behind it, there's probably